Good morning, trig fans. How we doing this morning? It's a beautiful sunny morning here. Hope things are going well for you and your family. Hopefully you're staying away from any type of sickness that may be going around. Hopefully you'll stay away from it. Sad day. Today was supposed to be opening day for the tribe. It's not going to happen. The importance to remember to keep our social distancing, do our part in regards to not passing this virus around, is very, very important because we want to try to get back to some sort of normalcy. Okay, I miss you guys. I wish you were in the classroom here with me today, but you're not here. So the tribe should be playing today. They're not going to be able to play today. So we will get back to normal as quickly as possible, but we have to do our part in regards to doing social distancing. Even though it may be inconvenient for us at times, it's going to help out everybody in the long run. So please keep your social distancing out there. Once again, if you have any questions at all about any of the problems that we are going through, please email me any type of problems that you're facing. We will just go over a problem or two from the review or from the worksheet I gave you yesterday. The homework for today will be to complete this all. So continue to work on this. And problems number 1 and 2, if you pull out your worksheet and problem number 1 and 2, if you don't have your worksheet, just hit pause and come back. Okay, or if you have to print off your worksheet. In the first section, problems number 1 and 2, it says find the principal value. I give you 2 values or 2 problems there. Now if you remember, the principal value is just determined by the calculator. It's all we have to do. Now what you have to make sure of is you need to make sure you're in the correct mode in your calculator. Once again, problems number 1 and 3 are in theta. Problems number 2, 4, 5, 6, and then 5, 6, 7, 8 on the back, they are in X. So my suggestion to you as you're going through these problems, do the 2 theta ones first. Okay, because 2 of them are going to be theta, everybody else is going to be in X and radians. So do the first problems number 1 and 3 first in the theta mode, in the degree mode. Make sure you change your calculator to a degree. Make sure it's in a degree mode, and then you can clickety-clack it through the calculator. Then change it to a radian mode and do the rest of the worksheet. That's my suggestion to you. What I'm going to do is go problem number 1 and 2. You just have to clickety-clack and put the answer down from your calculator. Problem number 3, we're going to take a look at problem number 3. Theta is equal to the inverse cosine of negative 0.73. Okay, so first off, once again, we need to note that we are in theta. So in our calculator, we need to make sure we change to a degree mode. Make sure you're in a degree mode before you go through the problem. Now, this is not one of the big equations that we deal with down at the bottom. So this is very general, basic equation where your amplitude is 1, period is 360, vertical horizontal phase shift is equal to 0. So when we have a basic equation, the key thing to remember is that the period is 360 degrees. In problem number 4, you're in X, so you need to make sure your period is 2 pi. Not 360, it's 2 pi radians. Okay, so if we take a look, go into my calculator, clickety-clack through inverse cosine of 0.73. Remember, we have principal value, which is your calculator value, your principal value, which is your calculator value. You come down to 136.9 degrees. Plus or minus the period end. So we have just plus or minus 360 n. That's our principal value that we pull off our calculator. Plus or minus the period end, and in these basic ones, the period is 360 degrees. Okay? Now, inverse cosine, we have to remember what we do with the inverse cosine. To get the second value with the inverse cosine, we have to take its opposite. That is correct. So we have negative 136.9 plus or minus 360 n. Now, if this was a sine, like we have in problem number 4, we have to deal with its supplement. Okay, so we either have to subtract from 180 if we're in degrees, or if we're in radians, we have to subtract from pi, 3.14. First three positives, first three smallest positives. This is 136.9. If I subtract 360, I'm going to be negative. I can add 360 here. It's going to make me positive, but it's going to be bigger than this. So we have 136.9. To get my second value, I go to my second one, negative 136.9 plus 360. So if we add those two together, you get 223.1. And then to go from 1 to 3, we can play leapfrog. We add the period, which is 360 degrees, so we get 496.1 degrees. Hopefully, if you've done the problem, you're just sort of checking through and, okay, I've done it. And once again, don't sweat if you're off. If you have 36.8 or 37.0, don't sweat that. Okay, just show me what you're doing here and you'll be fine. Now, if we go down to the bottom, I'll do problem number 6 at the bottom. We'll do a sine one. We have f of x is equal to 2 plus 3 sine pi over 2 x minus 5, and we're saying f of x is equal to 3.5. Okay, so we have one now where we have to sub in for f of x. So subbing in 3.5 is equal to 2 plus 3 sine pi over 2 x minus 5. Okay, our first two steps are going to be the same each and every time. As we've walked through this before, these first two steps are going to be the same. We are going to subtract the 2. So we have 1.5, and once again, I would just leave it like this, is equal to 3 sine pi over 2 x minus 5. The next step is to get rid of this multiplication by 3 so we can divide by 3. And once again, I would suggest you just leave this alone for right now. Leave it as a fraction. 1.5 divided by 3 is equal to the sine of pi over 2 x minus 5. Because our next step will be, how do we get rid of the sine from both sides? We take the inverse sine. So we can take the inverse sine in our calculator of 1.5 divided by 3. And you can quickly collect that straight through your calculator. Should get 0.52 is equal to, once again, I leave a space in there, pi over 2 x minus 5. Now comes the second value over here. To find the second value, when you deal with the inverse sine, you deal with the supplement. And how we deal with the supplement, we are in, once again, a radian mode. Make sure we are in x and radians here. Hopefully you were in x and radians. If you came down to the wrong answer here, check your mode. You may still be in degree mode from the problem we just did before. Okay, make sure we're back into a radian mode. So we have the inverse sine of 1.5 divided by 3. Then we deal with the supplement. And in a radian mode, this is pi divided by the, or minus the principal value. So we can go 3.14 minus 0.52. Once again, take this 2 decimal places so we can use a 3.14. And we get 2.62 is equal to pi over 2 x minus 5. Okay, and what do we do next? We got rid of the pi over 2, and we did that by multiplying by 2 over pi. So we're going to multiply both sides by 2 over pi. Which will cancel these out. So we have 2 times 0.52 divided by pi. Hopefully you get 0.33 is equal to x minus 5. And then we have 2.62 times 2 divided by pi. And once again, if I'm going too fast here, just hit your pause button. Hit your pause button, I'll stop. Yep, go again. I'll start back up. Should get 1.67 is equal to x minus 5. And our last step is to get rid of subtraction bias 5, so we're going to add 5, add 5, add 5, add 5. So we have 5.33 plus or minus the period end, and over here 6.67 plus or minus the period end. Now, the last thing is how we calculate the period. Once again, this here is your B value, and the period is calculated by 3, oopsie, I'm in radians. Two pi divided by pi over 2, which is like times 2 over pi. Pi's cancel. Pi's cancel, so we have a value of 4. So down here we have plus or minus 4n. Now we have to watch here with the first 3 smallest positives. Our first 3 smallest positives. I can either subtract or add the value 4 and continue to get values that I want as a solution. And in both cases, if we subtract 4, we maintain positive. So if I subtract 4 here, 5.33 minus 4, I get 1.33. In my second one, I got 6.67 minus the value 4, I get 2.67. And then to go from 1 to 3, once again, we play leapfrog. We add the period, which is a value of 4. We get 5.33. These are, once again, solutions to our equation. Okay, we are just solving an equation, is all we're doing here. We're solving an equation just like 2x plus 3 is equal to 5. We solve that equation. Well, this is a little bit more involved in regards to an equation. Once again, what I would like you to do, if you've not done it already, is complete the rest of this worksheet here. Complete the rest of the worksheet. I'll get something tomorrow that you'll have for the weekend that you need to hand in to me in regards to checking in on our progress and the work that we are doing here. Sort of like an in-class assignment, but obviously it's not an in-class assignment. You'll be free to use your notes and do it whatever you want to help yourself out, just not each other. Please, once again, don't refer to each other for help, but you'll be able to use your notes and take care of the work through the notes at that point. Hopefully this is helpful for you. Once again, please do complete what we are dealing with here. I hope, once again, everything is okay at your household. I hope you're staying ill-free. I hope your family's staying ill-free. If you have any questions, feel free to ask me, comment me. If I forget to do something, that is fine. Just comment me. and I'll get back to you as quickly as possible. Other than that, I miss you. I still miss you guys. I wish you were back in school. Let's continue to do our social distancing to try to make sure that we keep this virus and try to kill this virus out of here so we can get back to normal as what our new normal will be. And nobody knows that one right now. So hopefully, once again, that you're staying safe. Help your family out, help a neighbor out, go out there and clean up something for them. Go enjoy the beautiful weather that you're going to see today. Other than that, adios. I have nothing else for us. Have a great day.